At this point, you're probably thinking that all this clustering stuff is awesome and that you can get some real performance benefits inside of your application with doing just a tiny bit of work. You also might be thinking that, gee, seems like it's really great to just use more additional children. So maybe inside of my application, I'm going to just start up a whole bunch of different forks like so, and that means my application is going to run really fast. Well, unfortunately, life is not quite so simple. There's definitely a point of diminishing returns when you start using clustering. So in this section, and the next one or two, I'm going to show you some situations in which adding a whole bunch of additional children really has diminishing returns, and in some cases can actually be kind of catastrophic for your application. Before we start making any changes to our code base, I think that you can agree with me that we probably need a more scientific way of measuring how long it takes our server to process requests. In the last couple of videos, I've been going to localhost 3000 inside my browser and then refreshing the page as fast as I could. And that's definitely not very scientific. So let's first take a look at a little program that we're going to use to benchmark the performance of our server. And then we're going to come back and play around with the code inside of here a little bit. And I'm going to show you where clustering doesn't work out quite so well. All right, so I'm over at my terminal. I'm going to open up a second terminal window, still inside the same directory. Okay, so here's my second window. I'm still inside of my project directory. Now, I want you to know right now that the little program we're going to use to do this benchmarking is only installed by default on Mac OS and some Linux distributions. So if you are on Windows, the command that I'm going to use right here is not going to quite work out. And if it was easy to install this program on Windows, I would show you how to do it. But unfortunately, it's just kind of challenging on Windows. So if you're on a Windows machine, hey, don't sweat it. I encourage you to just follow along and watch these benchmarks. Honestly, it's probably just a lot easier if you kind of pay attention to what I'm doing rather than trying to replicate it on your machine, because there's kind of a few different variables at play here and how the exact numbers around all this clustering stuff is going to work out. So in other words, if you're on Mac OS, you can follow along with these commands, but if you're on Windows, I encourage you to just watch for a little bit. Okay, so here's the program we're going to use to benchmark our machine. The program is called Apache Benchmark, or AB for short. So you can put in simply AB, again, if you're on Mac OS, run it, and it will show you a bunch of help. You can read all this help stuff right here. Otherwise, obviously, I'll show you how to use it as well. So to use AB, we can specify a number of requests to make to some specific server. Apache Benchmark will then make all those requests, and then it will print out some statistics about how long it took for those requests to be processed. So let me give you a very quick example. Remember that back on our server right now, we have that /fast route. Let's try benchmarking how long it takes to run that route right there. So to do so, I can call AB-C, and we'll do how about like 50-N 500, and then localhost :3000/fast. So you can read this right here as use Apache Benchmark to make requests to localhost 3000/fast. Make a total, so -N right here means total number, so make a total of 500 requests. And the -C of 50 means use a concurrency of 50. That means try to make 50 requests at the same time. Now, of course, these requests might finish at different times, so it's not going to do it in batches of 50. Instead, it's going to try to make sure there are always 50 requests running at any given point in time. So try to make 500 requests and make sure there are always at least 50 requests pending. So I'm going to run this and we'll just see what happens. Okay, so as you can see, we get quite a good amount of output here. Now, usually there's a couple of different numbers that we like to look at. I personally like to see requests per second. So this is how many requests per second our server processed. I like to see the amount of time that it took on average per request. And then I also like to see how many, or kind of like what distribution for time of the like buckets of the requests made. And it's kind of like more of a histogram. Maybe not a histogram. Is it a histogram? I don't know. Someone who's really good with graphs can tell me if this is a histogram. Basically, this is saying that 50% of all requests were served or responded to within 70 milliseconds. But then one request at least took 130 milliseconds to respond to. Definitely kind of on the slow side. Okay, so now we have a much more scientific way of benchmarking the performance of our server. Now that we have this in place, let's come back in the next section and we're going to make some modifications to our server, and I'm going to show you exactly where clustering does not quite work out so well. So quick break, and we'll look into that in the next video.